Good afternoon, students. So in our last class we discussed about the evaluation of determinants with the help of the proper formula. So now here in our next topic is here, after completing the exercise 4.1, now the next topic is here, properties of determinants. So here actually these properties are very important examination point of view. So here the first property is here, like in this way given, if you see the value of the determinant remains unchanged if its rows and columns are interchanged. That means rows and columns are interchanged, that means all rows, all columns. So that means here you see already we mentioned in matrix, this one is the first row, second row, third row. Similarly here this one we mention as a first column, second column, third column. So now if you interchange the row and columns, so that means this one also we can say in case of matrix transpose. Now if you transform the first row A1, A2, A3, so we have to write in column form, you see here. Similarly the second row we write here in second column. Similarly the third row we write in third column. So in this way if you interchange the row to columns, now here the main the next determinant whatever we get, the result we get like in this way. After that, now after getting this one, so here you see this one is another determinant, this one is another one, because this one is in form terms of row given, so we interchange. After that we get this one. So now here if you see the first row first column element is same, but the here first row second column is A2, here B1. So obviously these two determinants are same, not same, different. So now here what happened, if you evaluate these two with the help of the property or formula whatever we know, if you evaluate this one and if you evaluate this one, in both cases we get the results are same. So that's why here the property mentioned as the value of the determinant remains unchanged if its rows and columns are interchanged. Is it clear? So that means simply we can say here, if we interchange the row to column, then after that if you evaluate, in both cases the value remain same. Is it clear? Okay. For this let's take an example here. So in this determinant if you see some elements are we consider 2, -3, 5, 6, 0, 4, 1, 5, -7. So this one is not fixed for 3 by 3 determinant. This one we write for 2 by 2, 4 by 4 also. Is it clear? So now after evaluating this result, the result, if you evaluate this result, then you get -28. So now here you see the first row is what, 2 -3, 5. So if we interchange the row to column, so here you see the first row we write, first column we write here 2 -3, 5 here, second one 6, 0, 4 here, 6, 0, 4. Similarly the third one. So after interchanging the determinant we get this one, and after that if you evaluate this result again you get -28. Is it clear? So here the task is what, you have to evaluate this result and you have to evaluate this result, and let's see what you get. In both cases if you get -28, -28, that means from here what we can say, if we interchange the row and column then the value will remain same. Is it clear? Okay. After property number 1, now the next property is property number 2. Here you see in this statement here what mentioned, if any two rows or columns, so it is not fixed for only for rows, this one we can do for column also. So that's why here written, if any two rows or columns of a determinant are interchanged, then sign of determinant changes. That means what, if we interchange two rows, it is not fixed that R1 and R2, it may be R1 R3, it may be R2 R3. So similarly you can interchange the column also. So if any two rows column if we interchange, the sign will be changed. That means if positive then we write in front of determinant we write negative, and if the determinant given in negative form then we have to write in positive form. Is it clear? So that's why here simply an example here we have done. You see the determinant we consider this result, so here we write interchange. The symbol of interchange is this one, which one we already discussed in matrix part. So R1 interchange R2. So that means the meaning of this symbol is what, we write in place of R1 we write R2 column row, and in place of R2 we write R1 row. So that's why here you see the first row is what, A1, A2, A3. So this one we have to write in the second place, and B1, B2, B3 here in second place given, so this one we have to write in first place, and we interchange these two rows, so that's why we write minus in front of this determinant. Is it clear? So it is not fixed that you have to always interchange only the adjacent row. This may be R1 interchange R3 also. Is it clear? So here not only the row, you can interchange the column also. So C1 interchange C3 also we can do. Is it clear? Okay. Next one is property number 3, and the meaning of the property number 3, the statement, if you see, if any two rows or columns of a determinant are identical. So here the meaning identical. So identical means if any two rows or any two columns are exactly same. The meaning of identical is this one. So exactly same. Now if you see this determinant, if you see the first row is here 1 2 3 and the third row is also 1 2 3. So in this case this one we can say identical. If all these three, the second row is also 1 2 3, then also we can say identical. So if any two rows or any two columns are identical, that means exactly same element. Remember, exactly same element, then we can say the value of this determinant. Without evaluating, we can say the value of this result is what? 0. Is it clear? So your task is what? You have to evaluate this determinant and let's see what you get here. So according to the property here, 1 2 3 the first row, 1 2 3 the third row. So two rows are same, so that's why these two are identical. So that's why what we can say, the value of this determinant is what? 0. Is it clear? Okay. Next one is property number 4. In property number 4, if each element of a row or column of a determinant is multiplied by constant k, then its value gets multiplied by k. Very simply, if you see here, we consider determinant A1, B1, C1. So here what you have to do, with this determinant we have to multiply it by a scalar. Suppose k is the scalar. So if we multiply this k with this determinant, in case of matrix, a scalar we have to multiply with each and every element of the matrix, isn't it? But in case of determinant, when we multiply it by a scalar, this scalar we have to multiply it with any one row or any one column. It is not fixed that you have to multiply it with first row. You can multiply this one with second row, you can multiply this one with third row, or similarly first column, second column, or third column. But the condition is what? When you multiply it by a scalar, it is fixed that you have to multiply with only one row or one column. Is it clear? Diagonally not possible. So in case of matrix we multiply with all elements, but in case of determinant we have to multiply with only one row or one column. Now here you see, in this statement what mentioned here, so after multiplying the scalar, if you evaluate the value, whatever the value you get here, and if you evaluate the determinant first and then if you multiply the scalar, then the values are remain same. This one mentioned actually here, but the actual meaning is what here, if you multiply it by a scalar with any row or any column, so we have to multiply like in this way here, with only one row or one column. Is it clear? Okay. Next property number 5. So here before this statement, if you see this example, A1, A2, A3 plus lambda 1, here B1, B2, B3 plus lambda 2, C1, C2, C3 plus lambda 3. So that means in this way, plus this may be given in second column or first column also. Similarly, this may be given in the first row, second row, or third row. It is not fixed that this one always given in the third column. So now here what you have to do, if you see first column, second column, we have to separate into two parts. So we have to write A1, B1, C1, A2, B2, C2. Similarly here A1, B1, C1, A2, B2, C2. So now the third column, if you see, two elements are here. One is A3 plus lambda 1, another one is B3 plus lambda 2, and the third one is C3 plus lambda 3. So what you have to do, in the first determinant we have to write down the first elements, and in the second determinant we have to write down the second element. So that means if a determinant given in this way, you can separate like in this way also. Remember, the first element we have to write in first determinant, the second element we have to write in second determinant. So this one given in row form also, or this scalar or the values are given in second row or third row or second column or third column also. It is not fixed that this one is exactly given in the third column. So here the same elements are we write in both determinant, and the third one A3 plus lambda 1. So in the first determinant we write A3, in the second one we have to write lambda 1. So easily we can separate like in this way a determinant into two parts. Is it clear? Okay. Now the next property is number 6. So in this property, actually the meaning is what? If any one row or any one column, if we multiply or add with another row or column, then after adding, if you evaluate the whatever the value you get at starting, the whatever the determinant given to you, if you evaluate the determinant, in both cases you get the same result. So that means the meaning is what? Here you see the value of determinant remains same if we apply the operation this. That means if suppose a determinant given to you, and if you evaluate and then you get some result there, and after getting this one, then if you apply any one of these two operations, that means here you see this type of operation already we have done in elementary operation to find out the inverse. So this type of operation already we have done. If you apply this type of operation and after that if you evaluate, then also you get the same result. Actually the meaning is this one. Is it clear? So that's why here the statements are given like in this way. These statements are also given in your book. Is it clear? So these operations are in our proof we used. Is it clear? So here Rij, why written here number of rows, here 1 2 3 4 5 maybe, so that's why symbolically we use here ing. Similarly in case of column. Is it clear? Okay. So now after discussing this 6 property, now let's take an example. How can we apply this property? So now here the question is given, you see, without expanding, that means we can expand here. Prove that this determinant value is equal to 0. So mainly here we need lots of practice here to get this result. So if you see the left hand side is this one result. So here first one is we mention R1, second one is R2, and the third one is R3. So now in this case one similarity is there. If you add R1 and R2, then you see here if you add R1 and R2, so that's why we transform R1 interchange to R1 plus R2. That means in place of row 1 we have to add these two. So that's why we write x plus y plus z, x plus y plus z, x plus y plus z, and the row 2 and row 3 are remain same. So that's why we write z x y 1 1 1. So in case of determinant, already we know a scalar we multiply with any one row or any one column. So in this case you see x plus y plus z, x plus y plus z, x plus y plus z. So x plus y plus z is common from here. If you take common, then here remain 1 1 1. But in case of matrix, when you take common, you have to take common from each and every element. But in case of determinant, you have to take common from any one row or any one column. So from the first row, if you take one common, then x plus y plus z common, then 1 1 1 1 1 1. So here written 0. Why? Since the row 1 and row 3, these two are what? Identical. So already we know if two row or two columns are identical, then the determinant, the value of the determinant is what? 0. So 0 into something, ultimately the result is 0. So here you see without expanding at any stage, we find out the value, and the value is what? 0. So in this way lots of questions are there to prove. So in our next class, how can we apply the properties and what are the techniques to find out the result. We discuss about this. So mainly here what you have to do now, from example 12, I think, yes, page number 115, from example 11 up to example 16. So these questions are, you have to practice first, and let's see what type of technique they are actually applying, and then after that we start the exercise 4.2 in our next class. Is it clear? Okay, thank you.